Hello everyone. In today's lecture, we will see the two problems of simply supported beam. In that, the first problem is that draw SFD and BMD means shear force diagram and bending moment diagram of a simply supported beam AB 4 meter long loaded with UDL of 10 kilonewton per meter up to 2 meter from B and a concentrated load of 12 kilonewton at 1 meter from A. So you have to draw shear force diagram and bending moment diagram. First draw one simply supported beam. So this is a beam, horizontal beam. On the beam support RA and RB support with span is 4 meter loaded with UDL. It having load UDL, that is uniformly distributed load of 10 kilonewton. It is up to 2 meter from the B, means it is started from B up to 2 meter distance. B to 2 meter distance, that point is called as a D point. And a concentrated load means a point load of 12 kilonewton at 1 meter from A. So 12 kilonewton load at 1 meter distance from A. So this is the diagram of a simply supported beam with point load UDL and their distance, and you have to calculate a shear force and bending moment diagram. So for that, first step is that take moment about any point, either you take A point or B point. Here we take A point. So summation of moment of A is equal to 0. Here clockwise forces are considered as a positive sign, anti-clockwise forces are considered as a negative sign. So first force RA, consider this value is 0 because there is no perpendicular distance. Then second force is 12 kilonewton, which is going in clockwise direction towards A. So consider plus. Movement means force into perpendicular distance. The value of force is 12 and distance is 1 meter, that is 12 into 1. A to C distance is 1 meter. So 12 into 1. Then next is UDL. First convert that UDL into point load. Convert that UDL into point load, and this is draw in between center of that UDL, means you suppose there is a 2 meter distance of the UDL, then this point load is draw at the 1 meter distance between at the center of that UDL. Now the value of that UDL is 10 into 2, that is 20 kilonewton. 10 into 2 because 10 is UDL's value and 2 is the distance, so 10 into 2 convert into 20 kilonewton. Their value of this point load 20, and distance is that 3 meter. 3 meter because this distance is about 1 meter and this distance is also 1 meter. So 1 plus 1 plus 1, that is 3. And last is RB, which is going in anti-clockwise direction. So consider negative. So minus RB into distance is 4 is equal to 0. After calculating this, all these value means 12 into 12 into 1 plus 20 into 3 is equal to RB into 4, and then divided by 4 to the our answer. So we got answer of RB is equal to 18 kilo Newton. Second step is summation Fy is equal to 0. For summation Fy, consider vertical forces. If forces are going in upward direction, consider the plus sign. If forces are going in downward direction, then consider the minus sign. So Ra, which is going in upward direction, so consider plus. 12, which is going in downward direction, consider minus. This point load is also going in downward direction, so consider minus. And Rb is going in upward direction, so consider the plus. So plus Ra minus 12 minus 20 plus Rb. The Rb's value is plus 18. So after calculating, we got answer of Ra is equal to 14 kilonewton. So this is about the calculation of Ra and Rb. Then next step is that calculate shear force value. And the shear force at A of left is equal to 0. A of left is equal to 0 means you should draw a vertical line or section line left of the A. This is the A point and you should draw this vertical line left of the A. Suppose here we draw the vertical line. After drawing, you will see the left of that section line there is no force, so A of left value is 0. Then second, A of right 14 kilonewton means now this section line is draw right to the A. Suppose this is A point, then you should draw this line here. Now you will see left of that section line there is only one force, which is RA force, which is going in upward direction, so consider plus sign. So plus 14 is the value of A of right. Next, C of left is equal to 14 kilo means this section line is drawn to left of the C, means some C point is here, so draw left of the C here in between these 2 points. Suppose this line is here, so now you will see the left of that section line there is only one force RA which is going in upward direction, so consider plus, so plus 14 answer again come. Then next is C of right 14 minus 12 is equal to 2 kilonewton means now this section line is draw right to the C. Suppose this C point, so we should draw this line here. Now see left of that section line there is a two forces RA and C. RA is going in upward direction, so consider plus RA. C is going in downward direction, so consider minus. So plus 14 minus 12, it is 2 kilonewton. Then shear force at D. Shear force at D means this section line is draw at the D point. It is no need to calculate D of left or D of right because in D there is no vertical load. So shear force at D, and now look left of D, so same forces are present, that is RA and C, which RA is going in plus upward direction, so consider plus, C is going in downward direction, so consider minus. So your answer is again 2 kilonewton. Then B of left is 14 minus 12 or minus 20 is equal to minus 18 kilonewton means now this diagram is draw left of the B, means you should draw this line here, directly draw on the B point. Now see left of that section line there are RA 12 kilonewton and there is UDL load. So RA is going in upward direction, so consider plus 14 minus 12 and this UDL is converted to point load, that is minus 20 kilonewton. So it is minus 18 kilonewton, and last is B of right is 0 kilonewton. This section line is come towards right to the B, and now you will see the left of that section line there are RA, C, UDL and RB. After calculating, the answer is 0 kilonewton. Generally simply supported beam shear force value, first value and last value is always 0. So this is about the calculation of the values of the shear force. And now our next step is to draw shear force diagram. For drawing shear force diagram, first draw one baseline or beam. That baseline is A, C, D, B. The next is A of left value is 0, A of right is 14. So draw vertical line of 14 kilonewton at point A. Then C of left is 14 kilonewton and C of right is 2 kilonewton. Means you should draw 2 kilonewton line on C, which is a dotted line, and C of left 14 kilonewton, which is draw with vertical straight line. Means C of right is 14 and C of left is 14 and C of right is 2 kilonewton. Then value of D is 2 kilonewton, so draw vertical line at D. Then B of left is minus 18, so it should be draw below the baseline because minus consider on the below the baseline. So these are the value plotted. Values are plotted on the points A, C, D, B. Now join AC. In A and C, in main figure, A and C, there is a no load, so it should be joined horizontally. Then come towards the CD. In between CD also there is a no load, so it is joined with horizontal line. Then come towards DB. In D and B there is a UDL, so it should be joined with inclined load. And it is joined with their sequence of the calculation, means first value is 0, so 0 is come here, then 14, so line come here 14, then come towards the again third point, that is 14, so it is joining on the 14, then come towards the 2, then again come towards the 2, and then goes to the 18. So this is the procedure for joining shear force diagram. The next step is, in this case, D to B, in this on this point, shear force diagram changes sign, that is positive to negative. So this point is called as a maximum bending moment, means that in this point having maximum bending moment value than the A, C, D and B, because this point changes positive to negative. And this point is called as a maximum bending moment. So first we have to calculate this value. For calculating this value, we have to first calculate distance. Means this diagram is again redraw. Next slide. This is a D point, this is a B point. Crossing point is called as the E point. This is a plus 2 value, this is a minus 18 value. Now we know the value of D to B is distance is 2 meter. We don't know D to E distance, so it is called as the X. So our first step is to calculate value of X. For calculating value of X, formula is X is equal to maximum shear force divided by UDL load. So maximum shear force means here is the maximum shear force, that is value of 2. This is the value of negative, so it is a minimum value. This is a positive value, so it is a maximum value. So consider here 2 here. Divide by UDL load means here consider original UDL load, that is 10. Consider this value 10, original UDL load 10 kilonewton per meter. So 2 divided by 10 is equal to 0.2 meter, means X is equal to 0.2 meter. Then calculate bending moment value. For calculating bending moment value, the sign considered is upward forces are considered positive, downward forces are considered as a negative force. So first value is bending moment of A is 0 Newton. Second is bending moment of C is equal to 14 into 1, that is 14 kilonewton. Bending moment of D is equal to 14 into 2 minus 12 into 1 is equal to 16 kilonewton. Bending moment at B is equal to 14 into 4 minus 12 into 3 minus 20 into 1 is equal to 0 kilonewton. So first value, bending moment of A, means you should look left of the A or right of the A and choose the minimum number of forces are present, that side you should be choose. In left side there is a no force, so consider bending moment of A is equal to 0. Then come at bending moment of C. Bending moment of C is equal to 14 into 1, means in left of the C there is one force and right of the C there are two forces. So choose minimum number of forces directions. So in left side direction there are minimum number of forces are available, that is one force is available. So RA is going in upward direction, so plus 14 into 1, it is 14 kilonewton. Then come at the bending moment of D. In D point, left of the D there are two forces and right of the D there are also two forces. So choose any one direction. Suppose in left side RA which is going in upward direction, so plus RA, that is 14 into A to D distance is 2 meter, so 14 into 2, 12 which is going in downward direction, so minus 12 into 12 to D is the distance 1, so minus 12 into 1. So calculating this, we got an answer of 16 kilonewton. And last point is the bending moment of B. In left of the B there are 1, 2, 3 forces, and right there is zero number of force. So choose right direction. So answer is 0. This is about the values of the bending moment. Okay. Now, but in shear force diagram, changes its sign positive to negative. So this point is called as a maximum bending moment, means that E point having maximum bending moment value than the A, C, D, B. So now we have to calculate the bending moment of that E point. So calculating the maximum bending moment at the E point. For calculating the maximum bending moment, we redraw the main figure. Some portion of the main figure we should be redraw. We're drawing only for B point and E point. There is no need to drawing left of the E side, because while we taking bending moment, at that case we selected minimum forces are present. That side we should be selected. So here only redraw minimum number of side forces. Here two forces are available in right of the E, so consider right of the E side. So draw only right of the E side. So here RB and UDL, and E to B distance is 1 meter, 1.8 meter. So maximum bending moment E is equal to RB's value is 18. So 18 which is going in upward direction, so plus 18 into distance is 1.8 minus that UDL convert into point load, center of that span, UDL span, and minus 10 into 1.8 into 1.8 divided by 2, means while we converting the UDL into point load, in that case we use UDL load into distance, so 10 into 1.8 into moment. While we are taking moment, in that case we also consider perpendicular distance. For considering perpendicular distance, we want distance that is from this point load to the E distance, which is half of the 1.8, so it is 1.8 divided by 2. After calculating, we got answer of bending moment of E is equal to 16.2 kN, which is greater than the A, C, D and B. So last step is drawing bending moment diagram. For drawing bending moment diagram, first draw baseline. Baseline A, C, D, E, B. We know the value of A 0. We know the value of C, which is a 14 kilonewton. We know the value of D 16 kilonewton, and we know the value of E, that is a 16.2 kilonewton, and we know the value of bending moment of B is equal to 0. Now join the AC, DE, B. First join AC with inclined line, because in between A and C there is a no load. Then join CD. In C and D also no load, so join with inclined line. Join DE and AB with parabolic curve, because in DE and AB there is a UDL is present. So this is about the bending moment diagram. In bending moment diagram, in this case, one more concept is come, that is maximum bending moment. A maximum bending moment means shear force diagram changes positive to negative sign or negative to positive sign, that is called as the maximum bending moment. The next second problem is that simply supported beam of span 6 meter carries a UDL of 1.6 kilonewton per meter over entire span and a point load of 3 kilonewton at 2 meter from right support. Draw SFD and BMD. So this is a figure. This is a simply supported beam with RA and RB support. Then 6 meter span is provided. It carries a UDL of 1.6 kilonewton per meter over entire span, means UDL is starting from A up to the point B with 1.6 kilonewton per meter, and a point load of 3 kilonewton at 2 meter from right support. From the right support there is a one point load, that is 3 kilonewton. That point load is called as C point load. Now first step is to take moment about any point, either take you A point or take B point. While taking moment, summation of moment of A, the RA, the value is 0. Then UDL is converted into point load. While converting this UDL, convert into at the center of that 6 meter. Suppose this is center, then convert here UDL to point load, means this distance is 3 meter and this distance is also 3 meter, and the value is that 1.6 into 6. This is 1.6 into 6, and while we taking moment about the point A, means we have to distance is this to this point, so 6 by 2, that is 3. It is 3 plus this 3 is going in clockwise direction, so plus 3 into C to A distance is 4 meter, and minus RB into 6 is equal to 0. After calculating, we got answer of RB is equal to 6.8 kilonewton. Then second is summation Fy is equal to 0. Here RA is going in upward direction, so plus RA. Then C is going in downward direction, so minus 3. Then RB is going in upward direction, so plus RB, that is 6.8, and this point load is going in downward direction, that is minus 1.6 into 6, that is 9.6. So after calculating, we got answer of 5.8 kilonewton. Then our next step is calculate shear force value. For calculating shear force value is that A of left is equal to 0 kilonewton. Means now draw one section line left of the, suppose you should draw a line here. Now see the left of that section line, there is no force, so consider 0. So A of left is equal to 0. Second, A of right is equal to 5.8 kilonewton. Means now this line is draw right of the A, should draw line here. So UDL is, there is no UDL is present. So now look left of the A. So section line only RA is present, which is going in upward direction, that is 5.8 kilonewton. This is 5.8 kilonewton. Then next, C of left, 5.8 minus 1.6 into 4 is equal to minus 0.6 kilonewton. Means this section line is now draw to left of the C, means you should draw directly on the C. Now look left of that line, there is looking RA and A to C distance of the UDL. Means RA which is going in upward direction, so it is 5.8, and UDL, here we are looking only A to C UDL, this distance of the UDL. So this UDL is converted into now point load. While converting into point load, consider 1.6 into distance is here consider only 4 meter, not a 6 meter. Here consider only 4 meter, because here we looking only A to C UDL, not A to B. Here only looking A to C, so consider distance only 4. So 1.6 into 4 is equal to minus 0.6 kilonewton. The next, C of right. C of right is equal to 5.8 minus 1.6 into 4 minus 3 is equal to minus 3.6 kilonewton. That means that this section line now draw right to the A. Now look left to the section line. While looking left to the section line, there is RA force, UDL force and C force. So RA force value is 5.8 kilonewton plus C, which is going in downward direction, so minus 3, and UDL, that is A to C UDL, is 1.6 into 4. 1.6 into 4, it is minus 3.6 kilonewton. Next is B of left. B of left is equal to 5.8 minus 3 minus 1.6 into 6 is equal to minus 6.8 kilonewton. Means that now this section line is draw left to the B or directly draw on the B. Now look left to the B, there are number of forces are 1, 2 and total UDL. Now this time UDL is looking from A to B, not A to C. Here UDL is here UDL is A to B. So consider distance UDL is 6 meter now. So RA which is going in upward direction, so plus 5.8. C is going in downward direction, so minus 3. And UDL is minus 1.6 into 6. It is minus 6.8, and last is B of right is equal to 0. In simplicity, for first and last force value is always 0. In the this is about the values of the shear force. Now draw diagram of the SFD. For drawing SFD diagram, first draw beam ACB. Then A of left is 0, A of right is 5.8 kilonewton. So this is the 5.8 kilonewton vertical load. Then C of left is equal to minus 0.6 kilonewton. The dotted line shows 0.6 kilonewton. C of right is minus 3.6 kilonewton. Means from C to this point is 3.6 kilonewton. B of left is equal to minus 6.8 kilonewton. So this is minus 6.8 kilonewton. Now join in between A and C. There is a UDL is present. So join with this is the inclined line. In C and B also UDL C and B. In between C and B there is UDL present, so it is also joined with inclined line. In this case, shear force diagram changes positive sign to negative sign here. So this point is called as a maximum bending moment, means that point having maximum value than the A, C and B. So in next step we should redraw this figure. This figure we should redraw A, C, and this point is called as the D point. Now we know the distance A to C is 4 meter. We don't know A to D, so called is it is A to D is equal to X, and D to C is 4 minus X. For calculating X, the formula is maximum shear force divided by UDL load. Maximum value is always positive value, so consider 5.8, and UDL load means original UDL load is 1.6. So X is equal to 3.6 meter, means that we know the distance A to D is 3.6 meter. So next step is calculate the values of bending moment. So first value is bending moment of A is equal to 0 Newton. The next bending moment of C is equal to 5.8 into 4 minus in bracket 1.6 into 4 bracket complete another bracket 4 by 2 is equal to 10.4 kilonewton. Bending moment at B is equal to 5.8 into 6 minus 3 into 2 minus 1.6 into 6 into 6 by 2 is equal to 0 kilonewton. First, bending moment of A. You should look left of the A. There is a number of forces are 0, so consider left side. So it is 0. Then come towards the C point, bending moment of C. You should look left of the C or right of the C. Number of forces are both sides are same. So consider any one direction. Suppose here we are considering left side. So RA which is going in upward direction. So 5.8 into A to C distance is 4 meter. Then UDL which is going in downward direction. So 1.6 minus 1.6 into now consider distance is 4 meter, not a 6 meter, because you only looking from up to A to C, not A to B. So 1.6 into 4 into the distance is 4 by 2. So the answer is 10.4 kilonewton, and last bending moment of B is equal to 0 because in right side there is number of forces are 0. So it is called bending moment of B is equal to 0. Now our next step is calculating the maximum bending moment. For calculating maximum bending moment, we again redraw some portion of the figure. Not complete figure should be redrawn. Only redraw some portion. Either you should redraw left of the D or right of the D of the figure. Here we only redraw the left of the D. While drawing left of the D, there is this beam. Then support RA. Then A to D is UDL. We already calculated A to D distance is 3.6 meter. That is X is equal to 3.6 meter. Now taking bending moment at D, for calculating bending moment at D, RA's value is 5.8, which is going in upward direction, so consider plus 5.8 into distance is 3.6. Then convert UDL into point load. Here center of the 3.6, so minus value is minus 1.6 into 3.6 into the half distance of 3.6 meter, that is 3.6 divided by 2. You putting this, all these values are in calculator, we got an answer of 10.15. Again I repeat this, we have to calculate maximum bending moment D. For calculating this, first calculate RA 5.8 into 3.6, then convert UDL into point load at the center, then take the point load's value 1.6 into span of the UDL is 3.6, so 1.6 into 3.6, this is the value of the force, then into, now take distance. For considering distance, we want distance from point load to the D. We know the total value, total distance is 3.6. So now divide 3.6 into 2, means half, consider half distance, because this point load is always at center of the UDL load. So 3.6 divided by 2, after calculating this, the answer is 10.51. And last step is drawing bending moment diagram. For drawing bending moment diagram, draw first baseline ADCB, then value of D is 10.51, value of C is 10.40, and B0 in between AD, UDL, so join with parabolic curve. In DC also UDL, so join with parabolic curve. In CB also, in CB there is also UDL load is present, so join with parabolic curve. So this is about the bending moment diagram. So these are the two problems of simply supported beam. In next lecture we will see the problems on a cantilever beam. Thank you.